Now we're going to be answering problems on function operations and composition of functions. So let's go ahead and answer problem number 1. So we have 3 given functions. We have f of x, g of x, and h of x. And for the first problem, we're going to be evaluating f of 1. So to find f of 1, we have f of x, which is equal to 2x plus 3. But since we are working with f of 1, we're going to replace the x value with 1. So we have 2 times 1 plus 3, which is equal to 5. So f of 1 is equal to 5. Now to convert this into coordinate of a function, f of 1 equals 5 is the same as 1 and 5. So your x value is 1 and your y value is equal to 5. So they have the same value but different notation. So for problem number 2, we're going to be working on function operation of h of 1 and g of 1. So h of 1 minus g of 2. Now h of x is equal to negative 3x minus g of x, which is equal to x squared. So in this particular problem, we're going to be replacing 1 with h of x. So we'll have negative 3 times 1 minus g of x is going to be, or x squared will become 2 squared. So we have negative 3 minus 2 squared is 4. So this is equal to negative 7. So that is the function h of 1 minus g of 2. Now for problem number 3, another operation would be f of x plus g of x. So notice that our parenthesis is no longer a real number but an x. So we're going to come out with an expression for this function. So f of x is equal to 2x plus 3 plus our g of x, which is x squared. So by simplifying this function, since there's nothing to combine, we can just rewrite it in standard form, giving us with x squared plus 2x plus 3. So this is now our f of x plus g of x, and we cannot evaluate it further because we're just working with the variable x. Now for problem number 4, we'll have f times h of x. So f times h of x is an operation of multiplication, so we're going to be multiplying f and h. So we'll have f is equal to 2x plus 3, and we're going to multiply it with h, which happens to be negative 3x. And since the little parenthesis is just an x, all we have to do is to simplify the expression by the distributive property. So we'll have negative 3x times 2x is negative 6x squared and minus 9x. So this is now the function of f times h times x. Now for problem number 5, we are seeing g of f of 1. So in this case, we're going to use the function g, which is x squared, divided by the function f, which is 2x plus 3. And from here, we're going to be replacing the x's with 1. So we'll have 1 squared all over 2 times 1 plus 3. And by simplifying the expression, we'll have 1 all over 2 plus 3, which happens to be 1 all over 5. So that is our function operation for number 5. And for number 6, we have a different operation. This is the composite function or composition of function f of g of x. So to find the composition of function of f of g of x, all we need to do is to write the function f, and the function f is 2x plus 3. And in this case, we're going to be replacing the x value of our f of x with the function g. And the function g is given by x squared. So we'll have 2x squared plus 3, which happens to give us 2x squared plus 3 because 2 times x squared is simply 2x squared. So this is our composite function for f of g of x. And for problem number 7, we have g of h of x. So just like what we did a while ago, we're going to start with the function g, which is x squared. And in this case, x will be changed by h, which is negative 3x. So x will become negative 3x, and we know that negative 3x squared is going to be negative 3x times negative 3x, which is 9x squared. And notice that for 6 and 7, we have an expression and not a real number because we are evaluating it with x. And for number 8, we'll have f of h of 1. So this time, we have a real number with our little parentheses. So we'll still going to start with f. And f is 2x plus 3. And we will replace the x value of your function f with h, which is negative 3x. So you have to replace x by negative 3x, and then it will still be 2x plus 3. And just by simplifying this will give us 2 times negative 3 by 1 plus 3, because x is supposed to be equal to 1. And by simplifying our expression, we'll have 2 times negative 3 plus 3, and 2 times negative 3 is going to equal to negative 6 plus 3, which is equal to negative 3. So that is our f of h of 1, or using composite function. Now for number 9, we have f of g of 0, but notice that the composite function is written differently because this is a different notation, but the process will still be the same. We have f of g of 0, which means we're going to be using the function f and replace it with g, and then replace it with 1 afterwards. Now another way of answering this is by solving the function g of 0. And in g of 0, we know that g of x is equal to x squared. So we'll just replace x by 0. So we have 0 squared. So we have g of 0 equals 0, which means we're going to replace g of 0 with the real number 0 so we can find f of g of 0. So now we will transform this to f of 0 because g of 0 is equal to 0. Now the function f, as we know, is equal to 2x plus 3. So we will replace it by f of 0. So we'll have 2 times 0 plus 3, which gives us 0 plus 3. So f of g of 0 is simply equal to 3. So this is another way of representing composite function. And for the last problem, we have 3 functions in one operations, h of g of f of 1. So just like what we did on number 9, we're going to go from the inside going out. So f of 1 is what we're going to be evaluating first, and we know that it will come from f of x, which is equal to 2x plus 3. And since we are looking for f of 1, we will replace x by 1, giving us f of 1 equals 5. So now f of 1 will turn into 5, so we'll have h of g, and f of 1 is now 5. So in this case, we're going to be evaluating g of 5 for our second level. So g of 5 will be coming from g of x, which is equal to x squared. So we will replace x by 5 so we can find g of 5. So we'll have 5 squared, and g of 5 is now equal to 25, which means if we're going to evaluate this, we are now going to evaluate h of g of 5, which happens to be 25. So g of 5 is 25, so we will replace this by 25. So h of 25 will be coming from the function h, which is negative 3x, and by replacing x by 25, we'll have negative 3 times 25 equal to negative 75. So negative 75 is our composition of function of h of g of f of 1.